And also, let me share the screen. Okay, now, and by the way, yes.
How many other functions is there to learn this year?
I think one probably just we are going to spend most of the time on the trigonometry, and it should be almost done. That's right.
Until June or no?
Until June.
Wow.
That's right.
Are we doing? What about the logarithmic function or no?
It's going to be level next month, level 4.
Level 4. Oh.
That's right. And now, guys, if you remember, if you noticed that yesterday I posted something on the Google Classroom, it was the same problem that we dealt with yesterday with the solutions, detailed solution. And now we are going to work with this, and I'm just going to give you maybe a couple of minutes that you see that if you can think of the best strategy to solve it, I do not want you to start solving it. Just think of the best strategy. Imagine that, for example, it's let's say, for example, this is a boat. That's right. I got the word. And this is Lucas standing on the boat here. This is Lucas. And look at this. This is a lighthouse here. Oh, guys, by the way, for the people who are at the other side of the class, Celia and Ella, can you see this, the board? Do you want to just come? We have 2 chairs here. One here and the other one is there. Do you want to change it there, or because I didn't notice it's too far away from me, unfortunately. If you want to change your seat, we have 2 very kind of a VIP seats here. Kind of a VIP seats. If you want, take a seat there.
Mr. Omid, if Lucas is on the boat, then who's in the lighthouse?
That's the mystery. We're going to solve it today. Who is in there? Who is in there? Okay, now, guys, please quiet. Now, and the thing is this. There is someone in the boat. Imagine this is Lucas here. And there is a lighthouse. And as you can see, as yesterday, there is a kind of a surface of the ocean. And now, what we see here is that, for example, we say that we take the surface of the ocean. Let me just do that on share the screen. We see that the surface of the ocean that we see here, we take this as a reference to measure the angles. Because remember, Sabrina, when we just want to measure the angles, we have to always have a reference from which side we are measuring the angles. Which side is going to be the fixed arm and which side is moving. And I say that arbitrarily, that I take the surface of the ocean as the reference to measure the angles. Then as a result, any angles which I measure with respect to that surface, which is above the surface of the ocean, I call that what? Angle of elevation that we had yesterday. Then now, as yesterday, we are measuring 2 angles with respect to the reference line that we are going to measure our angles. The first one is that with respect to, let's say, the points C and D, these are the bottom and the top of a lighthouse. The first angle, Chloe, that Lucas is going to measure is that from the where he is standing on the boat all the way to the bottom of the lighthouse, the sea. And he measures this angle at 35 degrees. Now, the other one, Simon, that Lucas is going to measure is going to be the top of the lighthouse. Again, look at that. The angle is just above the surface line. You see? Like the other one. That's why both of them are the angles of elevation. Now, and look at this. The angle that we measure, Lisa, for this one is 41 degrees. Then now we have 2 things, Daphne, that from C and D, we have just the angles. And now, look at this. We have also, we notice that the lighthouse is standing above, I should say, the distance that the lighthouse has to the, let's say, for example, this side that we are here. It is located at 52 meters away from the line of the reference. Now, we say that based on all the things that we have two angles of elevation and just a distance of 52 meters, we are expecting to find what is the value of the h, which is the height of the lighthouse. Now, this is the description of the things that we have to solve, and I just want to just give you 30 seconds maximum to visualize the problem and come with a strategy that you can propose to solve it. How can I solve this? Just having two angle of elevation and just a small distance. How can I find the height of the lighthouse? It's a very serious problem we're going to solve.
What is the thing for the department?
Oh, just visualize it and come with a strategy. Because the next one you're going to work with the partner, I'm going to assign something to roll before we take the first breath. Just visualize it and try to think, how can I solve it? It's a very, very, very serious real life application. If you read YouTube material from yesterday, life is going to be so. That's right. And now that's also a reference. Now, I'm gonna try. What do you think, my friend? How to solve this? It's a very important one, right? It's very important. Any idea? Nothing yet? Now, guys, I'm just gonna walk through with you how to solve this. First of all, guys, is it okay if I just close this one and I just do that on the Google Classroom? Not the Google Classroom, on the Zoom, because this one gives me more option for drawing and using, I should say, the ruler. Now, look at this. I'm just going to take this one. We had this one as a kind of a reference that we talked. We said that this one, we have it all the way to the lighthouse. We had two angles, one to here, and there was another angle, which it was all the way to the here. And what do we say? We say that this point is the boat that we are standing. This is A. This is B. This is C, the bottom of the lighthouse, and this is D. We had two angles. This angle, how much was that? 35, thank you. And how much was the other one? 41. Fantastic. And the other one is 41 degrees. Now, 50, huh? 52. No, oh, sorry. That's right, thank you. 52 meters, huh? Now, look at this problem. It tells you kind of a good strategy. When you get to a real world problems, do not just bother yourself with the diagram. Just convert it into a simple basic triangles.
What is 52 for CB or 52 for CB?
No, for CB, and now we are trying to find this one. This is the height of the lighthouse, right? Because between C and D, this is the lighthouse that you're trying to measure its height. Now look at this. Of course, the angle here, this is normal, based on the things that we had in the problem. And now what we are trying to find is this height, which is the between the angle, which is the length between the side of C to D. Look at this. Now, how many triangles you see in that problem? You see two triangles. And the strategy which we have is that every piece of triangle, imagine that you are going to swallow these triangles. You swallow one by one. You deal with one triangle at a time. I look into this, first of all, let me take this one. There's a little bit, I should say, in terms of size, huge. Let me put this one as 41. And I'm going to look at that. Look at this triangle, which I called it ABC. In this triangle, how many angles do I know about that? I have the value for it. 2, that's right. I have the angle 35. I know that, let's say the angle A is 35. But do you remember from yesterday that when we talked about the sine law, we said that when you are working with a triangle, there are two things very important. One of them is the size of the angle, and the other one is the length of the side just right in front of the angle. You remember that? We said that if we have, for example, this right triangle, not right triangle, any triangle is fine. For example, this is A, this is B, this is C. For each angle, there is a length right in just in front of it. And what we learned yesterday, without proving it at this stage, we said that the sine of any angle over the length which he is facing it, for all three angles, these ratios, of course, it is going to be equal. That's what you learn. Any angles in a triangle faces one side, and the ratio of the sine of that angle to the size of that side is going to be equal for all the other angles. This is a very important law, laws of the sine. Any questions so far? Now, then when I'm dealing with a triangle, it is always good that you have all these type of information parameters, the sides and, let's say, for example, the angles. For this triangle, which is ABC, I highlighted here the triangle ABC. I have the size of the angle A. How about, look at that, if this is the angle 35 degrees, what I'm going to be interested about that 35 degrees? The size, yes, Lucas. No, no, you say, please.
You know the angle of A and the angle of B. You can find the angle of B for the other one.
That's right, fantastic. And also, when I'm just standing at and looking at from the perspective of the angle A, the thing which is important for me is that do I have the side that this angle is facing? Which side it is facing? That's CB, and I have it 52 meters. Am I right? Then so easily I can build one ratio. What is that ratio? That's right. Exactly. And I say that, thank you. Sine 35 degrees over the size which this angle is looking at, which is how much? 52 meters. This is a ratio which is going to govern and rule on the triangle ABC. It's a very potent and important, I should say, ratio. Now, then I can build any other ratio, and I know that it's going to be equal to that. What is the other angle which I have? Yes. 90, fantastic. It's very obvious that we have the 90 because of the right triangle. Look at this angle B. Can I write this ratio that I said that the sine of 90 as Lex said, over which side? That's right, AC. From here all the way here. And guys, look at that. The length of AC is common between these two triangles. Isn't that right? And I said that it's going to be over the size of the AC. What is the relationship between these two important ratios? Equal. Fantastic. Exactly. And now, what is the value which is mysterious for us? We do not have it. AC. That's right. And look at this. AC, that's the thing which I do not know. And I can solve it just within a second. I love that. And look at this. In order to find AC, what I'm gonna do, have you made scrambled eggs before?
Yes. Yep.
For example, you have a frying pan, and this is the egg. You flip it upside down.
That's over easy.
That's right. What happens? Everything goes down, and the pan goes up. Look at this as a frying pan that you're making scrambled egg. You flip it upside down. Whatever is at the bottom goes up. What is at the top goes down. Look at this. I'm gonna just flip that frying pan, and from here I get 52 over sine 35. And on the other side, I get a C over sine 90. Am I right?
Yes.
Still, we do not have that AC value. And I say, in order to isolate the AC, there is something which is very bothering us. It's bothering us a lot. Look at the sine 90. How much is sine 90?
1.
1. And it vanishes. Sine 90.
Oh, that's like the calculation. That's like
And also, you can memorize it always. It is the most popular. It's like
Jennifer
it's
Lopez.
it's more popular than, for example, it's Brad Pitt of the trigonometry. You go outside and ask, do you know sine 90? They said that's the Brad Pitt. And it's always one, you always memorize it. And now then, as a result, Daniel, what do we get here? We say that then as a result, AC over sine 90 is AC over 1, which is AC. Then as a result, the length of AC is equal to 52 meters over sine of 35 degrees. Now, and they got it. And that length is measured just by using these very important, and please someone just find sine 35.
90, the answer for this is 90.66.
90?
0.66.
How much is sine 35?
35, 0.5.
Uh-huh.
0.5 cents.
And AC becomes 90, huh?
90. Yeah, 90.67.
Let's measure it as 91. Is it okay? We say that it's roughly, where is that one? And because, how did we do that? We said that we assume that in the, of course, during the test, you have the calculator, you can find sine 35. You get your calculator, you turn it on, put the button for sine, type 31, and it gives you that value, divide 52 over this. And then the size of AC is how much then? 91 meters. Any questions so far? No?
Whenever I do it on my calculator, it's the wrong point.
Because that has to be in degree, it has to be in degrees. You have the radians, I have to adjust it for you. I'm just gonna just fix it for you at the end of the class. And now guys, any question up to this point? What? Are we done?
No.
Never done.
Because we're trying to find this value, the height of the lighthouse. We only know this length. We got this common side using this very important, I call it the king of the triangles. And find this length. And look at this. We are interested for this length. And now right now, then we come ask ourselves, the length in the triangle, what is the thing that we have to know first? The angle which is faced by this length. Because that's always important whenever you have this angle B, and you need to know the size of it. B. You're looking for the edge. What is the angle facing the edge? 41 is from here all the way to the top. And that's right, 6. Why? Because look at that. Elisa, what is the angle from here to here?
41.
41 with the green one. Huh? Yeah. What is the angle from here to this here? 35. What is left in between?
6.
41 minus 35. Yes, everyone?
Yes.
Fantastic. And now, what do we have here is this angle. This angle is how much? 6 degrees. Oh, not 60. We have 6 degrees.
When we're putting it in the equation, it would make it perfect. Actually, doesn't matter. Never mind.
Sorry, what say that? No words. No, it's important.
No, I I realize I answered my question.
Okay. And now, guys, look at this now. Now we are going to the realm of the second triangle. And the second triangle, it gives us the value of the height of the lighthouse, because the height of the lighthouse is one side of the triangle which is built on the geometry of this problem. And look at this second. What is the edge? We do not know, but we know this angle. Am I right?
Yeah.
Now, then we can build this. We can say that the length of the edge, guys, and now look at this identity. I'm gonna flip everything upside down, and I put edge on the top and I write sine on the bottom, right?
Why are you looking at that?
Because that's always very important. Because you remember when we just started from here, because the thing that we're looking for was at the bottom, we looked at the scrambled egg on the right hand, we had to flip it upside down to get the unknown coming on the top. Because if the unknown is in the top, it's much easier to solve it. Then instead of writing sine A over A, you can just write A over sine A equals to B over sine B equals to C over sine C. You can flip everything upside down at once. Yes?
Yeah.
Now, because I'm looking for the edge, I put it on the top divided by the sine of the angle which is faced by it. This is 6. Am I right?
Yeah.
Sine of the 6. Now, I have one ratio, but guys, look at that. Have you heard that? They said that people are strong when we are together.
Yeah.
Yes? And now that's the same story here. One ratio is not strong. They have to come together. Then you need one more ratio to make it strong and to solve the problem. One ratio is one hand, one single hand. One single hand can do much. But if you have two hands, you have a strong, I should say, strength. Then now I'm looking for the second ratio to make this meaningful. What is the second ratio I can find?
Define the angle for C.
The angle for
Define the angle for C.
C. If I find the angle for C,
Define the reverse
if
angle.
I find the angle for C, I ask myself, what is the length?
Yeah.
If I find the angle for C, I ask myself, what is the length faced by C, this length AB? Do I have it? But I have the common length AC, and I know 91 meters. Then I ask myself, as long as I have this length, do I have the angle which is facing length, that length? Which is
Yeah.
D.
Can't you just do 180 minus
180 minus
whatever 35, 49 it is?
Exactly. Look at this.
55 and then it's 125. 125 plus 6 minus 180 is.
That's so true. I haven't used that
It's been a
word so
long time
long.
since I've heard that.
I haven't said that for a long time. That's so true. Look at this angle, guys.
49.
Angle D. Angle D is facing the sine 91, which we measured. Am I right? But at the same time, guys, we see two triangles, but they have a big triangle at the beginning. Look at this triangle ABD. Isn't that triangle itself? A, B, D.
So there's 3 triangles.
That's right. Look at this. We have this angle 41. We have this angle 90. What is D?
43.
D is 180 minus 90 minus 41. How much is that?
49. What?
40.
Yeah, 49.
Are you sure?
I did it
Checked
twice.
it?
I did it twice. 2 different ways.
We said 49 degrees.
Okay, like one day.
And now we got the second ratio. Look at this, Julia. We said that the second ratio comes because on the top, this one has a side. This one also should have a side. The side is how much for the AC is 91 over the angle, which is here, which is the sine of 49. Did you see what happened? Yes?
Well, why do you put AC over? 49.
AC, because 91 is the sine, and it is faced by the angle B, which we find it is 49 degrees. Then the ratio is going to be this, the sine over the length, which is faced by this angle.
Okay.
Because why? Because this is the sine law. It says that any angle, the sine of any angle over the size of the length in front of that should be equal to all the angles.
And AC is in front of B.
That's right. AC is the length just faced by this. Look at that. He is looking at this.
And since we found C and D, that would help us find the height, right?
That's right. And now look at this. Look at this, Elisa. You got the height right here.
Oh.
And look at this, Daphne. And now I'm looking for the height. I can multiply everything by sine 6. Then I say h equals to 91 over sine 49 degrees multiplied by sine 6 degrees. And it tells me how much is the height of the lighthouse. And we got it. If anybody got the chance, have a.
I got it, but I wrote 41 and 91. So actually,
Oh, it looks like that. That's right. It looks like 41. Let me correct it. This is 91. And we get h. It's not important how much we get, as long as the math that we use is very reasonable. Does it make sense to everyone? Yes? Any questions? Are you sure? Guys, that one was a very serious, I should say, real life application of trigonometry. I'm gonna post it, yes. You may have something like real life application on the test, but that one was really the most difficult one, I can say.
That would be like a very question.
I think so,
maybe
yes.
second hardest, maybe second hardest.
No, it's gonna be the hardest one.
No, is it?
That's right. But now, guys, if you have no questions, yes.
For the last step, why is
How did I find the edge?
oh, no, that's why I think you guys got
H, you multiply both sides by sine x, they cancel out, then you get x equals to 91 sine 49 times sine 6. Make sense? Awesome. Any questions? Are you good? Any questions, guys?
No.
No.
Yeah. I'm gonna give you a round of questions. Everyone feeling happy?
Yeah, but not that one.
I'm gonna post the PDF of the same thing that we did the detailed answer right now today. But right now, I'm gonna pause the recording right now. I'm gonna give you one handout that you start working on it. Okay, where is the Zoom?
Oh.
Let me pause the